Okay, this lesson today is the 8th grade 1.3 lesson. The objective is students will solve equations with variables on both sides by using properties of equality and collecting variable terms on one side. The standard that we'll cover today is 8EE 7B. The page numbers out of the blue Big Ideas book, the hardcover book, is pages 18 through 21. And out of the practice journal, it's page 14 for the lesson. Okay, so today we're going to be working where we've got variables on both sides of our equal sign. Okay, so we're going to be solving equations where if you look at your equal sign, you have variables on both sides. So to solve these equations, we're going to go ahead and collect the variables on one side of the equal sign and then work to get that variable by itself. Now, some of you prefer where you've got that X on the left-hand side, and if you want to do that, that's perfectly fine. But when I look at this sample that I have right now, if this is my equal sign, I really want to get the X's to one side. So I'm going to go ahead and work by getting rid of this first. Okay, and I'm still going to keep that 2 with that X, so I'm not separating it right now. I'm thinking of what is the opposite of a minus 2X? Well, that would be plus 2X. Okay, and the only time you do this is when you have the X's on both sides of the equal sign. So over here, I'm going to say plus 2X. Okay, that canceled that out here. So over here, I have 15, that's not crossed out, my equal sign, and then negative 7 plus 2. These are different symbols, find the difference, which is 5. The larger number was 7, it had a negative, so it's negative 5x. Okay, now I do want to point out to you that you would get the same thing if you went through and shifted everything to the left-hand side. So right now, this is what we just found out by working and moving the X that was with the constant or the plain number. We had 15 equals negative 5X. So just to prove to you that it doesn't matter which X you choose to move. Sometimes there's a smarter move that's less moves than another. Had I chosen to maybe move so that my X's were on the left side of the equal sign, I could do that. Okay, right now this one right here is negative 7X, while the opposite of negative 7 would be plus 7X. Okay, that cancels out. So here's my X's, so plus 7X. I'm doing like terms, right? So now I have a 15. Negative 2 plus 7 gives me positive 5. X equals, there's nothing here. Okay, so the problem with doing it that way, where I ended up moving the X's so that they were on the left, because that's where I prefer them, is then I have nothing that's left on the right-hand side of the equal sign. So that means I'm going to have to do another step to work to get so that there is something over there. So I'm going to move this constant right here, the 15, and I'm going to shift it to the other side. But I still, because I'm only moving that one part, I have to do the opposite to shift it to the opposite side. So right now this is positive 15. I would do minus 15. Minus 15. Okay, so you may now be looking at this compared to this. And some of you might say, but Mrs. Swanson, and one of them you have a positive 15, and the other one you have a negative 15. So you must have done something wrong. Remember, we're still working to get X by itself. So if I chose to work the first method, well, how would I get rid of this negative 5 away from the X? Right now it's multiplying, I would divide by negative 5. Divide by negative 5. So 15 divided by 5 is 3. There's one negative, so it's a negative 3. Is what X equals. So let's check and see what we would get here. On this side over here, I have a positive 5 that I'm going to move away from the X. So divide by positive 5. Divide by positive 5. Take note, we still did the 15 divided by 5 and got 3. There's still one negative. It's still negative 3. So we got the same answer either way. This format that I did, because I didn't choose to get the X's by themselves in the first step, I had to do one additional step, okay? But if you prefer to have the X's on the left-hand side of the equal sign, then you may have to do that extra step. Okay, and this is always confusing because you're so used to getting rid of that non-letter first. So this is just, you have to train your brain to look at these problems a little bit differently. Okay, so here I have a negative 3X. Here's my equal sign. I always do this because I know that I want to get all of my X's to one side of that line. Okay, and then I want the non-X's on the other side. So let's get rid of this 2X. right? Because here x is already by itself, but let's move this 2x. Okay, right now it's a positive 2x. The opposite would be negative 2x, so minus 2x. Negative 2x though, Mrs. Swanson. Well, negative 2 and minus 2, same thing. Whatever I did to one side, I have to do to the other. Okay, so now like terms, same symbol, find the sum. And if you're not good with these and you're practicing them, do it in your head, then check it on a calculator. Okay, because that's one spot where it's really easy to make mistakes. So same symbol, find the sum, which is 5. Apply the same symbol, negative, put my x, equals 19. Now realize that sometimes, you guys, you are going to get numbers where we have decimal answers. Okay, if you're ever questioning, like I know here, lots of times you guys are used to just getting those nice perfect whole numbers. I must have done it wrong. If you're ever questioning it, ask. I'll go through and check your work and make sure you did everything right, because sometimes you are going to get decimal or fraction numbers. So now when I go through, I want to get this negative 5 away from the x. Right now it's multiplying. We're going to divide by, take the negative with it because you want just x by itself. Divide by negative 5. Okay, so now if you go through and you divide that out, I can tell you right now it's going to be a negative answer because we only have one negative sign between these two. So I know it's negative. Now, if you're not comfortable dividing that out longhand, I'm not checking your division. You can use your calculator, 19 divided by 5. And if you know that rule of, hey, there's only one negative, then you don't have to figure out how to use that negative symbol. So you should have gotten negative 3.8. Okay, if I ever want to check myself, I can do that. And I know there's not too many of you that prefer to do that. But if I want to check it, I'm going to rewrite this. So I have negative 3 times negative 3.8 is what I just got for x equals 2 times negative 3.8. And then plus 19. So now I could use my calculator to go through and check it. Okay, and this is just my arrow. I looked at that at first and thought it was a number. Okay, so now if I do 3 times negative 3.8, those are two negatives. When I multiply and divide, I get to count negatives. So I know it's going to be a positive. So 3 times 3.8 gives me 11.4. Now, when I go to do this side over here, and I work that out, I should end up with 11.4. So I'm going to do the 2 times 3.8, and it's 7.6, but really that's a negative 7.6. Okay, so now you either have to understand how to use your calculator and do that negative sign, or you can think in terms of this is addition, so different symbols find the difference, which is what I'm comfortable with, and then apply the larger sign. So I know it's going to be a positive answer over here because 19 was larger. So I'm just going to take 19, find the difference, minus 7.6. And when I do that, it should give me 11.4, and it did. So that's how you can check yourself. I know it's a lot of steps. Lots of times I will just check with maybe a partner to see if I got the same answer. Okay, remember, if you didn't work together and you both get the same answer, most likely you're both correct. Not 100% of the time, but most of the time you are, okay? So you don't have to go through all of those steps of checking it, but if you're by yourself at home and you want to do a quick check because there I got, what was it, 3.8 or whatever it was, and sometimes you just really question yourself, is that right? You can always check by substituting in. Okay, so let's try one more. Okay, so looking at this, here's my equal sign, right? So we want to get the y's on one side and the constants, or in other words, the non-y's on the other side. And it doesn't matter which side you choose to move. Some of you, as you start working with these, will say, I always want to move the y's so that they are positive. Okay, but that is totally up to you. If you always want your y's on the left-hand side and you're comfortable with working with negatives, then it doesn't really matter. Okay, so I'm going to go ahead and work. I'm just going to work because I like to see the y's on the left side. So this right now is positive 4.5y, so opposite is negative. And we're taking the y with it right now because we're shifting to get the y's to one side. So that's why the y goes with it. So minus 4.5. Okay, so when I go through and I put these together, 2.5 minus 4.5, those are different symbols, find the difference. So the difference between those is 2. The larger number was negative, so I get negative 2y. Now if you need to use a calculator, use it. You punch it in exactly as you see it. 2.5 minus 4.5, it's still going to give you negative 2. So now I have plus 6 equals, and then I still have this -1. Okay, so now I'm gonna go through and get my constants or my just numbers. So right now I'm at +6, it's -6 is the opposite. -6. So -2y equals -1 minus 6 gives me -7. Okay, and once again, here I'm looking at it, and I myself, same thing, I myself am second guessing myself because I'm gonna get a decimal. So don't think that you're the only one that ever second guesses yourself. Sometimes when I work through these, I say, oh, I was hoping to get a nice perfect whole number. I must be wrong. Okay, be confident in yourself, work your way through it, check with a partner, or substitute in. So now when I go through to do this, let's say now I'm gonna get that -2 away from y. So divide by 2. -2. So now 7 divided by 2 is 3.5. Both of them were negative, so two negatives make a positive sign. So y equals 3.5. If you want to check it, you can substitute it in and check it. Check the partner, see if they got 3.5. That's what I would do. But I know sometimes you're by yourself and you just need to check it. So you just can substitute in. Okay, so I want you guys, we'll do a couple more of these and then I'm gonna have you do some of these independently. So let's look at number 1. Now don't worry about the picture part of this. I just pulled this out because it had some good repetition questions on it. I do have this worksheet. Not necessarily am I going to have you guys do it, but it is something where we can just get lots of reps of practicing getting like terms on the one side. Okay, so when I look at this, here's my equal sign. Okay, I like to have my R's on the left-hand side, so that's what I tend to move. Okay, so right now I've got -2R, so I'm going to say +2R. Get rid of that, so +2R. Now remember, if you just have an R, whoops, I did 21. If you just have an R, and that R is not showing up very well, that's the same as a 1R. Okay, so now 1R plus 2R is 3Rs. Then my equal sign. And now what I have left on this side can be simplified. I have a 19 plus a 29. So 29 plus 19 is going to give me 48. Now I can work to get R by itself. So now I'm down to a one-step equation. Divide by 3, divide by 3. So 48 divided by 3 is 16. Double check myself. It's late in the evening and I'm recording this and I don't want to make a mistake. Yeah, I was right. But see, I even second guess myself sometimes. So R equals 16. Okay, so let's try number 2. So once again, whenever you just have a letter, it's the same as a 1. So if you visually need to have that 1 in there, then put it in there. Okay, so here's my equal sign. Right here, I'm gonna work. I like to have the P's on the left side. So I'm gonna get rid of the one on the right side here. Right now it's a -1P, so I'm gonna say +1P and +1P. So now I have 2P, and I still have -30 equals -4. Okay, so now we're to our two-step equation. You know, we're just working right now, getting that P, getting all the P's to the one side. So the opposite of minus is +30. +30. Now I'm comfortable with integers. So I have 2P left here equals negative and a positive. I find those are different, so I find the difference. The difference between 4 and 30 is 26. Apply the larger sign, that would be positive, so it's a positive 26. Now I have to work to get that letter P by itself, so right now it's times, we're going to divide by 2. Divide by 2, P equals 13. Okay, so let's go through and do number 3. So I've got B minus 24 equals 16 minus 3B. It doesn't matter which B you move. Okay, but here's my equal sign. I have to get them all to one side. So I like to work once again with them to the left, but I'm comfortable with negative numbers. So right now this is minus 3B. I'm going to say plus 3B because that cancels it out. So over here plus 3B. Now remember that is 1B. So now I get 4B minus 24 equals 16. Okay, now we're down to our two-step equation. So get rid of anything that doesn't have the letter directly attached. Right now it's minus 24, we're gonna do plus 24. Plus 24. So I have 4b left here equals 16 plus 24 is 40. So now work to get the b by itself. So now it's 4 times b, we're gonna divide by 4. Divide by 4. I just found out that b equals 40 divided by 4 is 10. Okay, so I want you to go ahead and pause the video. You're gonna write down numbers 4, 5, and 6 on your whiteboard. And you can do them one at a time if you want, and then just jot your answer off to the side. Work through these, and then in just a couple of minutes, I will go through what the answers are. I'm not gonna go through step by step, but I want you to pause your video and work your way through those because you yourself need to practice those steps. Okay, so go ahead and pause your video now. Okay, so hopefully you got those answers for 4, 5, and 6. And if you didn't, key thing is like, don't erase your work if you're working through these. If you're doing them on the whiteboard, it's probably good practice to maybe check in between each of them. I know that's hard to do on the video, but maybe check with a partner around you if you've got somebody else around you. Otherwise, maybe if you're doing this from home because you're just practicing it, maybe these are good ones to do just on paper so that you can go back and look through your work. If you're not getting them, make sure that you check with me and I'll be glad to look through your work and help you through your mistakes. Okay, so here's the next step. We're gonna go through and work distributive property. So remember, we did work distributive property in lesson 2, and I know that we practiced it more the other day, and this just takes practice. It takes practice, practice, practice. So remember, distributive property is when we're gonna go through and distribute whatever's on the outside of the parenthesis to whatever's inside. And make sure that you distribute this to both items inside of the parenthesis. Okay, you can't forget to do that. Okay, so when I look at the first part of this, we have negative 2 times x. Well, that's gonna give us negative 2x. Now, this is where it's tricky because sometimes kids just wanna do the negative 2 times 5. But here's the thing, we had another negative in there. And I know there it's x minus 5, but when you're doing this distribution, if there's a negative sign there and there's a negative on the number on the outside, you have to combine those. So it's really negative 2 times negative 5. 2 negatives make a positive, so it becomes positive 10 or plus 10 equals, okay, if you don't like fractions, unless I'm specifically going through and checking to see if you know how to work fractions, you can change these to decimals. If you don't like to look at it this way, you can think of this as 0.5x minus 0.5x, if that's what you would prefer. Okay, so I'm gonna go through and I'm gonna distribute. 6 times 2 is 12. 6 times a half, or 0.5 if you're using your calculator. I oftentimes think of what is half of 6. When they're nice simple fractions like that, that's 3. So there was a negative sign there. This was a positive, so it ends up being a minus, so a negative 3x. So now we're back to what we've just been working on for those first 2 slides. And we're gonna go through and combine like terms. So the step that we just added was that distribution, which we did work distribution last section, so that's not brand new. But now I'm introducing it where we now have, here's our equal sign, and now we've got x's on both sides. Okay, so if we go through and we work our way through these, I like to work x's on the left side, so I'm gonna get rid of this one. So plus 3x, it's the opposite. Remember, if you shift it with the x, you just do the opposite of the number. So plus 3x. So now I get negative 2 plus 3 is 1x plus 10 equals 12. And I know some of you will start seeing some shortcuts. Do I really have to rewrite the whole problem? No, but lots of times what happens is kids forget which way they moved their numbers and they end up with both their variable number and their constant number on one side of the equal sign. So that's why I choose, as I'm teaching this, until you get comfortable, to do it step by step and not take a shortcut. Eventually, once you're comfortable, you'll start to see that really, oh, there is a shortcut here. I could write this here, cross it off, and write this here. But the problem with that is kids cross off the wrong side and then end up with the number, the constant number, and the variable number on the same side. Okay, so I'm just gonna work it off of this down here. So minus 10. And doing it this way helps me to see which one I need to move. The more comfortable you get, you'll be able to go ahead and do that little shortcut that I was just showing you. So minus 10, but you have to get comfortable first. 1x equals 12 minus 10 is 2. So x equals 2, or 2 divided by 1 is 2. Okay, so let's try another one. So we're just adding a piece, and really it's not a brand new piece. It's something that you guys have already worked with, but now they're combining it with giving us variables on both sides. Okay, so this one's easier than the previous one. So we're gonna distribute. Don't forget to distribute to the second term that's in there. That's the most common made mistake. Okay, and no, I don't distribute any further. Here's my equal sign. So I don't have any distribution on the back side. So I've got an equals 2z here. And then 6 times 4 is 24. 6 times z is 6z, and there's one negative, so minus 6z. Okay, so now this is what I'm seeing, you guys. I see I've already got the z's by themselves over here. And I know normally I like to work where the z's are on the left-hand side. But honestly, I don't want to do any more steps than I have to. So I'm going to get rid of this minus 6z. It'll save me a step. So right now, if it's minus 6z, we're going to do plus 6z. It's opposite, right? So plus 6z. Plus I get to work positive numbers this way. So I have 24 left on that side equals 2 plus 6 is 8z. So now to get z by itself, well, right now it's times 8. We'll divide by 8. Divide by 8. 24 divided by 8, z equals 3. Okay, so I just found out that z equals 3 there. Okay, so this is out of your workbook. So your journal book, if you want to flip to, let me check the page number really quick. Page 14 of your journal book, this is question number 3. So you can just fill in, hey, I'm giving you a homework assignment. Key thing is, or answer. You're not just writing in the answer, you're showing me the work. Okay, so we're going to distribute first. So 5 times p is 5p. 5 times 6 is 30. That's a plus, so both of them are plus, so plus 30 equals 8p. Okay, so once again, guys, here's my equal sign. I've already got the p's over here by themselves. I'm not going to shift the 8p to the left side just because that's how I prefer to work with the letters. I'm going to get rid of the 5p. It's fewer steps. So right now it's a positive 5. The opposite is negative 5p or minus 5p. Minus 5p. I have 30 left on this side of the equal sign. Equals 8 minus 5 is 3p. So now we'll divide by 3. Divide by 3. P equals 30 divided by 3, which is 10. Okay, so as you're doing that in your workbook, you need to have those steps down. Do not just write P equals 10 and think that I'm going to accept that. Okay, so I'm going to go ahead and put this next one up. And you're going to pause your video and you're going to work through it. And then you're going to check your, not check your work, but check your answer. I'm not going to show the work when I do this. Okay, because I want you to go through and practice it on your own, but yet have the confidence once you check your answer. So go ahead, pause your video, and work through number 4 out of your workbook. Okay, key thing on these, anytime I do problems and they're part of your homework, I'm not just checking your answer, guys. I will be checking through your work. So if you're not pausing your videos and actually going through and practicing the concepts, the steps that are being taught, it's going to show up. So make sure that you're going through. And if you're not understanding, well, I didn't get 41. I don't know where I messed up. See me. I'll look through your work. I'll try and figure out maybe where we made a mistake. It could be a simple mistake. It could be that you totally forgot maybe to distribute on one side. But I'll be glad to go through your work and look through it. It's also nice because you have a lot of classmates that would be willing to do that also, to kind of compare work step by step. Okay, so sometimes we're going to work with some real world problems, and actually the activity that goes with this lesson is working with some geometry, but I've chosen to do that activity after I taught the lesson. I know in the book it comes before that, but I just in the past have had kids that they just get frustrated, and I don't want to see them frustrated. So I've chosen to go through and teach the lesson and then have you apply that to geometry, okay? So it says the circles are identical. So if they're identical, they're exactly the same in size. What is the area of each circle? So take note that when we look at our answers, we do have two of them, A and B, that are just numbers. And then we have two of them that have the pi sign, okay? And remember, pi is like 3.14. So as we're working through this, I'm going to guess, unless we get a perfect number, they're going to leave our answer with pi, okay? So they're asking for the area. So my first question is, how do we find the area of a circle? Pi r squared sounds like area to me. When I need circumference, I just use pi d. Now I need area. Pi r squared sounds like area to me. So that's the formula I'm going to use. Okay, so now I have to understand what r is. And r is radius, and this is my radius. Okay, so it's part way across and part of an arch, or arc, whatever. So now when I go through and I do these, my question is, I know that this radius is x plus 2. What's this radius here? If they showed the whole red line was 4x, then half of that would be 2x. So here it's r equals 2x. Okay, so here's my question. So what do we need to know about the radius of each circle? Well, we just found out what that was. How do we find the area of each circle? Okay, so they want to know what is the area of each circle. We don't have to figure out what the radius is. They want to know the area. So when we go through and we look at this, if I substitute in this where r is here, we have pi times x plus 2, it's my radius squared. So we've got 2 squared is 4, x squared, right? Because really I have to apply this squared to both of these. So 4x squared, I'm not seeing that one up there. Okay, so then let's go through and substitute in on this one. So r squared, 2 squared is going to be 4x squared. I'm getting 4x squared on each of these times pi. And we've already squared what the radius is. So it says the circles are identical, so the radius of each circle is the same. What is the area of the circle? So let's look up and see what we've got for our samples here. We've got A says it's 2, B says it's 4, C is 16 pi, and then D is 64 pi. So when we go through and we look through this, what do you suppose we could do? Because I'm getting 4x squared on each of these. Do you suppose we could tie in maybe that simplifying, if I go through and I simplify as if these are equal to each other? Just considering what we learned in this lesson, let's try that. So I've got my radius is 2x for one of them, and that's equal to x plus 2. So let's see if we work off of that, if it gives us, because what I got here is pi times 4x squared. Well, we don't know what x is, so we can't really figure out if it's one of those two. So let's go through and see if we can figure out what just the radius itself is. So let's use this where I took each of these and I wrote them out equal to each other. Okay, can we combine like terms? Yes. Let's get rid of this 1x here. So minus 1x minus 1x. So I get 1x equals 2, divide by 1, divide by 1, x equals 2. So what is the area of each circle? Well, we just found out that x equals 2. So x is 2, but they want to know the area. So if I substitute in 2 here. So what's 2 plus 2? That's 4. That's our radius. So now we've got pi times 4 squared. Whoops, and I wrote r squared, 4 squared. So 4 squared would be 16, and then we have a pi. This would be our final answer. Okay, lots of steps to get there, but I was trying to see if we could figure it out without having to go through and use, but we didn't know what x was here, so we couldn't go through and figure for one of those A, B, C, or D. So we ended up having to use what we learned in this lesson where we set them up equal to each other. So that's pretty complex. That's stepping out there. Okay, so there's one more real life application. It says a boat travels X miles per hour upstream on the Mississippi River. On the return trip, the boat travels 2 miles per hour faster. How far does the boat travel upstream? So here's what we have to realize is between these 2 points, I'm just using these red points, which are now blue, it is the same distance, but it took less time one way than it did the other. Okay, so we're traveling the same distance. We were just traveling faster one time than the other. So looking at the picture, it looks like when we did this, for 3 hours one way and then 2.5 hours the other. So X represents the miles per hour. So just to give you an example, let's say you traveled 5 miles per hour. Then going upstream, it would be 3 times 4 because you would go 4 miles each hour, right? Okay, so we are trying to figure out what our miles per hour is, okay, our distance. Okay, so now if I go through and I look at this, well, it's going to be 3 times x, the number of hours that we traveled. So 3 hours times our speed, sorry. And then the second trip, and I don't like that I reversed the colors, so I apologize. The second trip was 2.5 hours. And so we're going to take 2.5 times x, which is our miles per hour. But then we went 2 miles per hour faster. So that's where that plus 2 falls into play. And they gave us that right here. Okay, so now looking at this based on what we've done, our first step is going to be to distribute. We want to simplify as much as we can. Okay, so here I get 2.5x, that's an ugly 5. And then 2.5 times 2 is 5, so plus 5. Oops, I don't need that. And over on this side, I still have 3x. So 3 hours times our speed. And then I did the 2.5 hours times our speed, but we increased it by 2 miles per hour. That's why there's this plus 2. Okay, so now let's get the x's to one side. All right, so we're going to go minus 2.5x to get rid of it. So minus 2.5x. We get 0.5x here equals 5. Okay, if you're not comfortable with decimals, pull your calculator out if you need it. So I'll divide by 0.5 to get x by itself. Divide by 0.5. So 5 divided by 0.5 is going to give us 10. So in other words, we are traveling x equals 10, and x was representing the miles per hour. So on our part that took us 3 hours, that's where we were traveling 10 miles per hour. And here we would be traveling on the way back 10 plus 2, 12 miles per hour. Okay, so then the question says, the speed of the boat on the return trip is x plus 2 miles per hour. So how far does the boat travel upstream? So if we're going upstream, we travel 10 miles per hour at 3 hours. So 10 miles per hour at 3 hours, 10 times 3 would be 30 miles. Okay, once again, sometimes those story problems are tricky because you're trying to pull the information out that you need. Key thing is that you're trying, and just always remember you're applying whatever skill we were practicing to those story problems. So good luck. If you need any help, make sure that you ask.